this is a good one. You'll like it. You may need a calculator for some components, so if you get out a calculator, that would be great. All right. So, first part is more parametric. Now, there's a certain special type of parametric for projectile motion. If, for example, I threw something like that, or I shot something out of a cannon, or shot a bullet, or all those are projectile motion problems. And though we could do a y-x equation and blow time off, it's more common that you would look at this either in a parametric or in a vector kind of way. And there's a lot of overlaps. All right, so here I'm giving you two equations, one for horizontal position depending on time, and one for vertical position depending on time. The original thing was cost at an angle of pi over 4 with the horizontal at an angle of 30 meters per second. Now then, I would love for you to actually not just see the equations, but understand them. So can you please explain to me how this calculates horizontal position? What does it do? Thank you. Okay, how does this work? What is 30 cosine pi over 4 doing? All right, so would you agree that the vector, the velocity itself is 30 meters per second, but it's at an angle of pi over 4. If I wanted to talk about how fast it's moving horizontally, so as this thing goes this way, how fast is the horizontal position changing? Then I would need to figure out not what's the rate in that direction, but what's the rate in this direction. What should we call that? E sub x, the velocity in the horizontal direction. How would you find the velocity in the horizontal direction? Cosine, yeah. Cosine's the adjacent to hypotenuse, so you use cosine. So this is the horizontal rate, or yes. That t, did I typo that? Is that supposed to be in the cosine argument, or no? It's a normal t.
It's a normal t.
So is this a cosine equation or a linear equation? It's a linear equation. This is a constant rate. If you like, think of it as 15 root 2 if you did cosine of pi over 4 and simplified. This is just a linear rate of change. Okay? So this x depends on rate times time. And that's all that really goes into it, is the initial movement and what it does to the horizontal position. Now, vertical, a little more complicated. Vertical, you can see there are 3 components. So let's talk about what each one does in turn. What is this guy there?
Acceleration.
That's acceleration due to gravity. Okay, now, gravity obviously is affecting the vertical position. What is 30 sine pi over 4t doing? That's the vertical component to the velocity times time. And what do you reckon that 2 is, though it's not in the word problem? What do you think it's reference to? Why is that 2? That's the initial height at time 0. That's redundant, I guess, but you get the idea. The initial height must have been 2 meters. So there are 3 parts to the height. Yeah? All right, cool. At what angle will the projectile hit the ground? Is it just, it'll come down at the same angle as it went up at? So I had some people say it's hit pi over 4 again. True or false? False. Why?
Because it started at 3.
Yeah, it's starting at 2. It's not starting at 0 and going back to 0. It's starting at 2 and going back to 0 or going to 0. So the idea that this angle and this angle would be the same, probably not so much, all right? So we need to know, what is this angle? How do you reckon we should do it? Let's go here. Is this a linear path? No, it's not. So delta y and delta t seem like, not so much. But if you were to zoom way in, is that locally linear? Yes. Now, if you zoomed way in, then that's not delta y anymore. That's dy. And dx. And the angle there is what we got to find. All right. Now talk to me then. How are we going to find this angle? Inverse tangent of dy dx. How do we typically do dy dx in parametric? Dy dt over dx dt. All right. Now then, calculator time or not yet? Let's do a little more without a calculator, shall we? Inverse tangent of, what's dy dt? Negative 9.8t. Think of that big expression as 30 root 2 over 2 or 15 root 2. You down? So what's the derivative of 15 root 2t? 15 root 2, and the constant's derivative is 0. Okay. What about dx dt? It's just 15 root 2, and the derivative of t is 1. Weak. Cool. Am I ready to put that into our calculator? The time of what? Yeah, we need the time it hits the ground. It's not, hey, figure out the angle at any old time you want. We need the angle of when it's hitting the ground. So we need the time it hits the ground now. So would you feel free to use your calculator there. And however you choose to do it. I've been playing around with this polynomial tools thing here. I don't know. No, that's not it. Yeah. I thought there was an easy way to solve polynomials or quadratics based on the degree, but I can't remember where I found it. Now I can't find it again. Is this one? Three, two, yes. Negative 4.1. What is it? 15 root 2, 15 root 2. Sorry, I'm so slow. Oh, shucks. What did I do? Did I not do numeric? Not say. They won't let me do 15 root 2. That sucks. Never mind. I failed. Okay, so help me out here, people. What did you get for the time? 4.42 something or other? Blah, 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 blah. All right. Question. Without using your calculator, what will the inside be? Think dx, dy dt, and dx dt. Will the sign be, sorry, not the number, the sign. Positive or negative? Dy dt, what's the sign? Negative, why? Because it's going down at that point. What about dx dt, positive or negative? positive because it's going right at that point. So I would expect a negative. Now, I should have put this in the question, but it usually reads in an AP test like find a theta between 0 and pi over 2. In other words, don't give me some negative angle. Give me a normal-ish angle in radians. Now, by lava zones, if I ask the calculator to give me the inverse tangent of a negative, won't it give me a negative angle? Yeah? So that would be something like negative. Did anybody do that yet? 0.866? 806? That's radians, obviously. Now that's negative. We would take the absolute value of that because we don't care about it's technically really what the calculator is doing is saying, oh, you want me to find this angle down in the ground? No, we want this angle here. And so it's 0.806. Are you with me? Are you looking? Yeah. That's right. All right. It's probably 40-ish degrees. I don't know. So far, so good? Fin. All right. Let's go on to the second idea. Second derivative in parametric. I am so glad because I get to teach after Ms. Cannon and you have good calculus basics. So you understand the idea of derivative with respect to. That's not blabby-blue. I hope. Okay? So, for example, if I took the derivative with respect to t for time of both sides of this, then the derivative of the left, what is it? dv dt, easy enough. The derivative of the right, what is it? 4 pi r squared dr dt. And we know that you have been taught that you, in essence, are using the chain rule. You're taking the derivative of the outside, but then you have to take the derivative of the inside. The derivative of r with respect to t is dr dt, right? Okay, cool. Now, let's talk notation here. If I take the derivative, if I write y equals x to the fourth, and I take the derivative with respect to x of both sides, then actually, I think to get the point I want you to do this. Would you write y equals big old space x to the fourth? All right, sorry, I didn't mean to waste your time. All right, now, if I want the second derivative, then I need to take the derivative with respect to x once of both sides. And then once I do that, then I have to take the derivative with respect to x again. We. All right, now the part I want to focus on is notation. This is so hard to teach an AB kid. You know, when you, or a Calc 1 kid, because they just happen, you write the second derivative this way, yeah? And trying to explain to a kid why the 2 goes there, here, but there, that's hard to do. They don't, it's whatever. They just eventually say, whatever, just, oh, you know what the answer is. But over here, didn't you take the derivative of y? Now that's why we write it that way. Or Leibniz wrote it that way, something like that. You know, but that's that. And the derivative with respect to x twice over then is that. The right side is a non-issue as far as, because we're taking the derivative of x with respect to x, it is 4x cubed and then the derivative of that, so the right side's not the focus. I want to, it's the left side I want to focus on. All right, now then, my point then is just to prime the pump or get you ready for parametric derivatives. You have to be good with your notation to find the second derivative parametrically, because people want to just take the derivative of the derivative. There's a little more to it than that. I will explain. So, how do I find dy dx? dy dt over dx dt. Okay, so dy dt is 4t cubed, and dx dt is 2t, and if we simplify, that's 2t squared. We? So that's the first derivative. So the problem is we're taking a derivative with respect to x, but the variable in that is t. So we're going to have to make sure we're careful with that. If I want the second derivative then we obviously are taking with the derivative with respect to x. So if I take the derivative with respect to x of my first derivative, then I'm taking the derivative with respect to x of 2t squared on down. So the left side is the second derivative, which is fine. But the derivative on the right, be careful. So what's the derivative on the right? 4t dt dx, because I took the derivative of the t with respect to x. Read? Now that's kind of wacky. We don't really usually take the derivative of t with respect to x. We take the derivative of x with respect to t. Now I could go back and take the derivative of t with respect to x here, but it's far more common that you would say, well, that would be the same as if I had dx dt in the denominator. Isn't dt dx in the numerator the same as dx dt in the denominator? All right. Well, that then means that really when we do the second derivative, we take the derivative, but because of the chain rule, we also actually end up dividing by dx dt. What was dx dt again? 2t. Is that what you said? 2t. And so our second derivative is just, okay? So that's the process. You know, students don't have any problem with it. It's fine. You guys don't have a problem with it. So, would you try this one on your own, please? My answer is obviously unsimplified. What's our more likely multiple choice answer? It'd be negative 3 over e to the 2t, or negative 3 to the negative 2t. One of those is probably a cleaned up version. You with me? All right. Just to make sure you're prepared for the ugliest case scenario, try this one. This one gets pretty hairy. It's just there's a lot of trig in there, which I know you have good trig skills, so you'll be fine. doesn't match what I did in my last class, but I must have made a mistake there. Are you getting something like this? Negative 4/9 and sine cubed-ish? Yes? Okay, so now the pi over 3 is negative 4/9 cube roots of 3/2. So what does that imply? Concave up or concave down? Concave down. Okay. Cool. What's this graph look like? Come on. How do you eliminate the parameter? Divide and square. So what would this be with eliminated the parameter? X squared over 9 plus y squared over 16 equals 1. Are you with me? Yeah. And at pi over 3, I'm thinking maybe 3/2. So it's about here. Does it make sense that it's concave down at that point enough? Sure. Yeah. Okay. Alrighty. Now, last but not least, let's see if you are at the AP free response level or not. This is an exam question from 2016. The first 2 questions are calculator options. This is question 2, so you may use a calculator here. And you should be able to do it in 10 minutes or a little more. You have 15 minutes for the AP test, but this ain't the AP test, so you get it done in 10. 3 minutes. You might get out a pen to write yourself some notes about anything that you're changing to correct. You can reference. Okay, let's see. What do you say? What do you say? How do you think you did? I think you'll be a very good room. All right. The first part, would you agree that you needed to do two things? Integrate x prime and use the initial condition, yes? So, if you have an integral from 0 to 3 of x prime, give yourself 1. If you have x initial or 5 somewhere in your work, give yourself 1. And if your final answer is correct, and by that I don't just mean horizontal and vertical. If you found the horizontal is 14.377 and the vertical is negative 0.5, then give yourself 4, give us 3 points there. All right? Any questions about A? Yes?
Well, if we don't have like x is 0, we just have 5.
That's fine. Yep, absolutely. Okay. B, the slope we know is dy dt over dx dt, yes? It feels like you really should communicate, hey, this is where 1/2 is coming from. Obviously we're pulling from the graph for the slope, but you should communicate that you're talking the derivative of y over the derivative of x. So I believe the answer itself would not be enough. It would be bald. You would need the derivative over the derivative communicated. You need dy dt over dx dt communicated. And then 0.05. You done? That was all 1 point. The third decimal is 0, so that's why they're not showing. Okay. The speed, for the benefit of those who have not smoked physics, do you agree speed is light velocity but without the direction component? It's how you're changing position over time but without direction. Now, doesn't that mean I don't care about horizontal position change, I don't care about vertical change, I just want to know how fast is it going? Speed then is like a hypotenuse. Okay, it is how fast you're talking and changing without respect to direction. So speed is the square root of x prime squared and y prime squared. It's like how fast it's changing horizontally and vertically in a Pythagorean theorem calculation. So your speed, if you have that, that's 1 point. If you have that, then you're eligible for the answer point, and that's 1 point. Obviously, if you don't know what speed is and you wrote a bunch of crap, then they're not going to read for the answer point. You have to have the word communicated, then the answer. Cool? What if you don't have this shown and you have the correct answer? What do you get? 0. You get 0 out of 2. Okay, bald answers get nothing. D. D. Okay, I didn't do this first part. I kind of jumped to it here. Do you agree that distance in linear movement, we do when you did Calc 1 distance, you integrated absolute value of velocity, right? But what is absolute value of velocity? It's speed, okay? So in 2 dimensions, you also find distance by integrating speed. Speed times time, intervals, lots of little changes, gives you distance. Now the problem, what is the problem with that? Yeah, you don't have an equation. Can you find y prime? Yes, but is it the same for the whole region 0 to 2? It isn't. You have to use a piecewise function. You have to go 2 integrals, one for y prime from 0 to 1. What's y prime from 0 to 1? -2. And what's y prime from 1 to 2? 0. And you really should be communicating what you use there. So it's a piecewise calculation because y prime is different for both of those chunks. And so your answer is 4.349 or 4.350. 1, I think if you had this or this, this definitely has to be there. For the expression for distance, I think if you didn't do this and you went straight to here, I think you would be good. Actually, you need y prime in there somewhere here, don't you? If you did a piecewise with y prime and then said what y prime and y prime are, that probably would be okay. Okay? 1 for the integrals and then 1 for the 2. How'd you do? Very good. You got 1?
2.
Okay, 2? All right. Could you get 9 if I asked you tomorrow?
Yes.
Okay, I won't ask you tomorrow, but I'm just curious. Okay, good deal. Step forward. Here we go. What are your team questions? 23. 15. 26. 26 is a problem. 23, 15, 1. All right. What? 14. Okay.
Ask for the derivation, Gary.
23.
I did not understand the notation.
Yeah, 23 was a good one. I love it. This is a really clever problem. I think it's well constructed. All right. So your goal is to find C, eh? I had a dickens of a time getting started because I felt like, well, wouldn't I need to anti-differentiate that so I could put C in? But how do I take the antiderivative if I don't know F? So what's to be done? Well, I just said it. How am I supposed to take the antiderivative if I don't know F? That means the question is, the problem is I don't know F. How can I find F? Take the derivative to get F. Okay? If you take the derivative, and that tells you that f of x is, what's the derivative? Cosine of x. Therefore, the function is cosine. Now let's see if that helps me. From c to x of cosine t dt is sine of x plus 1. Now I'm feeling it. What's the antiderivative of the left? Sine or negative sine? Sine. From c to x is equal to sine of x plus 1. That means sine of x minus sine of c equals sine of x plus 1. What does that imply sine of c equals? -1, so c must be, they said c is between 0 and 6. So give me an angle where sine is -1 between 0 and 6. Alrighty, that was a good question. 15. 15, it's not replaced, is it?
Yeah, it's a trig I
Yeah, so if this were a definite integral, I'd have no problem. It's a quarter circle area, yeah, or a half circle area, but it's an indefinite integral problem, and that means you need to know trigs. What trig? X is 4 sine theta. Then it becomes 16 minus 16 sine squared theta. That seems like it'll work. So now let's find the dx that goes with it. What's dx? Or cosine theta d theta, we? Okay, let's talk constants. What's the overall constant? I get a 4 here and a 4 there, so 16. What's the overall trig when it's all said and done? Cosine squared. This is the square root of 1 minus sine squared, which is the square root of cosine squared, which is cosine times cosine is cosine squared. Cool. There is still an issue, so I'm going to keep going. How do I integrate cosine squared? 1/2 plus 1/2 cosine 2 theta, yay? So that's something like 16 times, or do you want to just call it 8? What do you say? Okay, so let's call it 8 times, when you integrate 1 with respect to theta, what do you get? Theta plus, and what's the antiderivative of cosine of 2 theta?
1 4
Over 2, so 1/2 sine of 2 theta, yay? Now the problem with that is that this trig fact is about sine of theta, not 2 theta. So how do I deal with that problem? You know theta, not 2 theta. So we need to change this guy. How do we do it? 2 sine theta cosine theta. And so we get something like 8 times theta plus sine theta cosine theta. Now we're rolling. Now we can draw the triangle. The triangle is something like x over 4 equals sine theta, yay? X is opposite, 4 is hypotenuse. So the square root of 16 minus x squared is adjacent. So what's theta? It is thank you, Bethany. And what about sine theta? And cosine theta. 16 minus x squared. All right. You'll follow? Okay. 15, check. 1. Question on 1. 1. What a mess. Let's start basic. The total, we're trying to minimize the cost, yeah? All right, so we need a cost function. We can't minimize anything until we have a cost function. Let's, generally speaking, isn't it the cost of the top, cost of the bottom, and the cost of the sides? It says here that it's 2L and H. There are 2 things that go into the cost of the top. There's the top and bottom being $8 per square meter, but I would then have to find how many square meters, right? How many square meters to the top? 2L. The bottom is the same, so it is also 8 times 2L. The cost of the sides, they're $4 per square meter. How many square meters to all the sides? 2HL and so there's 1HL and there's 1HL, and then I also need to 2 H's. So 4 H's, yeah? You cool? So cleaned up, I have 16L plus 16L, so 32L plus 8HL plus 16H. Cool? Now that's 3 variables. If I could help it, I'd like to get it down to 2 variables. What's the other relationship between the variables? The volume. The volume is 16, yeah? And the volume is also 2HL. So let's say that L is, or H is, I don't care which. L is 8 over H, yeah? So the cost is 32L times 8 over H plus, wow, now I'm behind the other class, that's crazy. 8L, does that get you started? H, I want it to be all H's, don't I? What a dum dum. You get the idea. Make them all H and then go. Does anybody need 14 still? Can we get you started with 14? We already go. 14 is pretty straightforward. Oh, okay, cool. I made a mess of this. Shall I continue? Or are you good?
Well, how are we gonna find out if I was working this is one of them? I don't know, that's like,
Babe, your voice is lovely.
You can get an LSU, it was either one that you.
Alrighty. CNTN.
I should say for macro, I should say
yeah.
They're gonna be mad for a problem.
Yeah. And then
Except for the calculus part, except they.